Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. And if you'd like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem. We have a problem in probability for exam P. X is a random variable with probability density function, which is equal to e to the minus 2x for x greater than or equal to 0, and 2e to the 4x for x less than 0. Let t equal to x squared. Determine the probability density function for t for positive values of t. So an important observation that you should make immediately is that the transformation t equals x squared is not one-to-one. So you won't be able to use the standard formula for the probability density function, or PDF, of a transformed random variable. And what should we do then? Well, the answer is, if you read my study manual, you know that you prove the formula for the PDF by using the CDF technique, the cumulative distribution function technique. So you simply figure out the CDF of the result of the transformation from the original CDF. That's the CDF technique. It's very simplistic, really, and, well, it requires some work sometimes, but it's a simple approach, really. That's what we're going to do. I use the subscript to indicate the random variable to which we are referring in notation. I use that in all of my texts, so I'll do that again here. Also note that the random variable t only assumes non-negative values. It's the square of x, so that's why it's greater than or equal to 0. And in fact, t is positive with probability 1 because the probability that t is greater than 0 is the same as probability that x squared is greater than 0, and that's 1 minus the probability that x is equal to 0. Which is 1 minus 0 because x is a continuous random variable, so its probability of being equal to 0 is 0. So t is positive with probability 1. We also note that the cumulative distribution function of t at 0 is 0 as well. For t positive, well, when t is positive, the CDF of t, which is the probability that t is less than or equal to t, is the same as probability that x squared is less than or equal to t. And then, what is that? Well, that's the probability that x is between, remember, t is a positive number, so its square root exists. We can calculate it. And probability that x squared is less than or equal to t is the same as probability that x is between minus square root of t and square root of t. Well, great, but x has a different formula for density for negative values and different one for positive, so we need to separate those two for calculating probabilities, because x is a continuous random variable, so we're going to calculate its probabilities using its density. So we can write this as probability that x is between minus square root of t and 0, and union of that event with x between 0 and square root of t. But of course these are mutually exclusive events, so the probability of the union is sum of probabilities. And then we calculate the probabilities of x being between minus square root of t and 0 using the integral of the density in that region, which is 2e to the 4x. And for x between 0 and square root of t, the density is e to the minus 2x. So we just need to calculate these two integrals. Well, the indefinite integral of 2e to the 4x is 1/2 e to the 4x. We evaluated from minus square root of t to 0. And the integral of e to the minus 2x is minus 1/2 e to the minus 2x. And we evaluate that from 0 to square root of t. And that ends up being 1/2 minus 1/2 e to the minus 4 square root of t minus 1/2 e to the minus 2 square root of t plus 1/2. So 1 minus 1/2 of e to the minus 4 square roots of t plus e to the minus 2 square roots of t. And the density is a derivative of this. Well, the derivative of 1 is 0, so all we need to do is just take the derivative of that second term, and that's going to be negative 1/2 times the sum of the derivatives of the two expressions there, which are, so negative 1/2 times, and the whole thing inside is that derivative. It's e to the minus 4 square roots of t times negative 4 times 1 over 2 square roots of t, because 1 over 2 square roots of t is the derivative of the square root of t. And this is a composite function, so we need to take the derivative of the exponential and then of minus 4 times square root of t. And of course, the exponential derivative of that is the same thing, minus 4 square roots of t. So the linear expression, negative 4 times something, the derivative of that is negative 4. And the derivative of square root of t is 1 over 2 square roots of t. And actually, it works the same way for the second term. Instead of e to the minus 4 square roots of t, we have e to the minus 2 square roots of t, but otherwise it's the same thing. So we end up with e to the minus 4 square roots of t over square root of t plus e to the minus 2 square roots of t divided by 2 square roots of t. And if we change the order, that's e to the minus 2 square roots of t over 2 square root of t plus e to the minus 4 times square root of t over square root of t, and that's exactly answer A. Please remember this is copyrighted material, and the problem comes from a sample published by the Society of Actuaries, so the problem itself is the property of the Society of Actuaries. The solution is mine. I reproduced the problem with permission from the Society. Good luck in your studies, and good luck on the test.